Hey, good evening, folks. Welcome back. It's been a while since we last connected. So it takes a great pleasure to introduce Alexander, who is a Kaggle Grandmaster and a competition Grandmaster to that. And he leads the team, the AI team at Burbank, if I pronounce it right. So
Yep.
over to you.
Okay, thanks. Hello, folks. My name is Ryzhkov Alexander, and I'm the head of AutoML group in Sber AI Lab. So for today, we are going to talk about our open source solution called LightAutoML. And my talk today will be separated into two parts. First of all, we discuss some theory points and the advantages for business. And after that, we will talk about some practical examples of LightAutoML usage, and we will try to find out how to use it for solving just business needs. So let me share my screen really quick and check that you can see it. Yeah, okay, cool. So now you can see it, and we are ready to start. Okay, so first of all, we need to talk about AutoML itself. There are two different variants which can be the explanation of AutoML. First of all, it's an AutoML in narrow sense. It is just an instrument for automatic ML model creation. So the data preparation, the feature engineering are just for data scientists, and the AutoML model just find out the best construction of the model. And for sure, we want more broader automation. So we are talking about AutoML in broad sense. So it is a technology or framework which helps people to automate the whole ML model and pipeline, including data preparation, feature engineering, feature selection, model building, hyperparameters optimization, and even model deployment, inference in production environment, and so on. And as for money, we have two different parts for sure. We have open source solutions, and our solution is open sourced. It is available on GitHub and PyPy, as well as H2O, AutoML, AutoGluon, Tport, AutoScalar, and many more open source solutions in AutoML sphere. And for sure, we have proprietary solutions like Driverless AI, Google Cloud AutoML, and so on. But for today, we are going to discuss only open source solutions as we are in this category. So if we have so much solutions, why do we need to create one more? So first of all, we have a variety of data types, just numbers, categories, dates, non-structured texts, and sometimes images, and so on. And we need to preprocess them to suit the models. So we need to have advanced preprocessing inside AutoML solution. Secondly, when our customers came to us and just talk, we want this feature inside the model or this type of model inside the whole model. So we figure out that we need some customization for our solution pipelines, and it's really crucial for our users. Thirdly, the amount of data we have is pretty huge. It's like hundreds of thousands of rows, or even millions of rows, and thousands of features, because we have pretty good data sets in our company, and not only in the main company. So the existing open source solutions can train very slow on them because of their brute force structure, or brute force nature, you can call it so. That's why we figure out that we need to do something with it. Moreover, when you build models inside the bank or inside other business company, you need just to create several models inside the same task or inside the same ML task. Why it could be so? You can have different client segments, and you just need to build the separated model for each of these segments. And here you just you have two options. You can run AutoML separately for each task, or you can just build one model, figure out what's going on, what works best, and reuse it for other segments. And for sure, the second one is pretty much faster than the first one. And the last but not the least is that for our bank and for sure for other banks in Russia and not only in Russia, we have so-called regular requirements. For us, the requirements of Central Bank of Russia, and for companies in Europe, it could be European Central Bank requirements. But for sure, we need to have an opportunity to build like interpretable models, and it should be done automatically. So to go with these specifics, we created LightAutoML. It is a cross-platform modular framework. Cross-platform is because you can install it on every operation system you have. So it could be Mac OS, it could be Unix, it could be Windows, and so on. And to be customizable, it is a modular framework where you just build your pipelines from so-called modules or some steps. We will talk about them a little bit later. So just to figure out what Llama is itself, it is AutoML solution on one hand. So we have end-to-end preset suite for ML task solutions, for binary classification, for multi-class classification, and for regression for sure. And you can also use it as a constructor for ML pipelines. So you can build your own custom pipelines using predefined blocks. And you can also create your own blocks and put in inside our created ones. So the target audience for us are data scientists who just solve ML tasks every day, and developers as well who just know the basics of ML maybe, and know how to code on Python. And currently we have several implemented pipelines. So it is black box preset for building black box models. It is white box preset for interpretable models. And we have NLP preset for working with text data, working with neural nets, and something like that. And if we discuss the possible example of build ML pipeline inside LightAutoML, it can be divided into several steps. First of all, we have a data processing block, which receives the user data, figure out what it is inside, just do basic cleaning and automatic feature typization. It's a crucial part of data preprocessing step, because sometimes it understood that you have just like a real variable, but it should be a categorical one for better model accuracy and so on. So we just figure out that this current feature should be categorical, even it is real as as it is inside user dataset. So at the end of this step, we have AutoML dataset with categorical feeds, dates, numeric feeds, and maybe texts if we have so. And after that, we should go to model training. But before we go, especially for model training, we need to select some important features. But in default pipelines, we have so-called garbage feature deletion or removal. So we just drop several features which didn't help the model to be to have good accuracy. So we don't work with a real feature selection here. We just try to reduce the training time because it is crucial if you had thousands of features and only 100 of them are really useful. And after that, we are going to model building step. So here we have two different models, for example. It's LightGBM and linear model. And both of them have feature engineering block beforehand. It is so because for different types of models, you need to have different feature engineering. For example, you can have one-hot encoding for linear models and mean target encoding for gradient boosting ones. So the data preprocessing and feature engineering should be pretty different for these types of models. And so we have these two different blocks. And as for models, you can see here that we do cross-validation training and receiving so-called out-of-fault predictions. So it is not overfitted predictions for the whole train. And we receive one column with predictions for LightGBM for the whole train and one column for linear model as well for the whole train. But we can't go live with two different predictions. We should receive the final model. And we have done it with just type of robust weighted average composition. Which can drop some models if they have pretty small weight. So if it is less than 5%, it should be dropped. So your model will be more stable and it will work faster because you just use only one part instead of two, for example. And if we go to the high-level description, we have different applications for LightAutoML from the data source integration. It's just like the first step during ML pipeline. And we can go up to model inference and production with the help of our industrialization parts, which are built inside our inner company called Sber Cloud. And as for models, as for LightAutoML structure inside, here I want to talk a little bit more about post-processing step, because just like anything else inside ML pipeline, I think is pretty common. So we have now model generation report. So you can receive HTML page with info about the model you built. And currently we are working about 3 steps of post-processing about interpretation. So we need to figure out what's going on inside the black box models, because inside usual white box models you are you have pretty good interpretation of it because of its simplicity. We also work on distillation. So we try to figure out how to build our models with the more simpler model. And for sure, we need to monitor our models in production, because if you just put it into production for several years, in some time in the future, it will be not so actual as at the time you put it into production. So you need to figure out when you need to replace it with the newer one. So we are currently working on these 3 blocks here, and I think we should release them sometime in this year. And for sure, as we have a lot of AutoML solutions, so we need to check how to measure between them. So, and how to choose the best one, or how to choose the worst one. So if we Google it, we just take a look at so-called OpenML Benchmark. It was introduced on ICML 2019 on AutoML workshop. And the idea behind this OpenML benchmark is pretty simple. The authors have around 40 data sets for both binary and multi-class classification. And here we have several columns of graphs. So first one is for small binary classification tasks. It's just like less than 10k rows. The second one is medium binary classification tasks. It's from 10k rows up to, I think, 200 or 250k rows. And the last column stands for multi-class classification. Here, the data sets were different, just like less than 1,000, or even, I think, 50k of rows. So it was like really different data sets here. And as we go for specifications for this benchmark, we have ROCOG for binary classification and log loss for multi-class classification as a metrics. And we for each data set, we should go with 10-fold stratified cross-validation. And for each 9-fold, we can train using 8 virtual CPU cores and 1 hour time. So in these specifications, all the AutoML solutions were trained, and we receive the results for each particular fold inside this cross-validation scheme. But these results wasn't aggregated by AutoML solutions, and we just create 3 methods to do that. So first row here stands for wins by task metric count. So for example, for the first one, we can see here that for small binary data sets, tuned random forest just have 3 wins, and it just have more wins than any of AutoML solutions. That looks pretty crazy. And the second row here is the mean leaderboard position between AutoMLs. And the last one just works with scores, and it is a mean normalized solution score for each task. So what we can see here from all these data sets? We can see here that on the small binary classification task, we have pretty the same scores for each solution, including unit random forest and random forest itself. But if we go for the usual for businesses, medium binary classification and multi-class classification, here the LightAutoML has pretty good scores in each metric. So it could be possible to solve your business task with LightAutoML on a pretty good level. But I need to mention here that these results are the official results that were released on 2019. And for now, the authors of the benchmark are going with a new version of this benchmark, and we are inside this benchmark, but the results of this run is currently is not finished, and so we are just waiting for that. But we have done our own run of this benchmark, and you can see the results of it here. So if you want to check them, you can go this link and check. And the results are pretty much the same. But we are still waiting for official results. And the last part of the theory about AutoML is so-called white box AutoML. So it's the thing when we try to make interpretable models. Interpretable models for us are classic scoring card model building, and we try to do it with minimal possible decrease of the quality compared to black box AutoML. What is classic scoring card? The example of it is on the left, and here we have just like a simple table where we have some points for intercept, some points for each bin for each feature. So if you have this scoring card, you don't need a computer, you don't need Python, you don't need anything instead of calculator or your math inside your mind, and you just can create the prediction for each object, just summing the points for its features. And the theory behind this scoring card is a logistic regression model built on weight of evidence decomposition of the features. So we just create something like bins. For example, here you have ext source 1 feature, and it has bins, the first one from minus infinity up to 0.2. The second bin is from 0.2 to 0.38, and so on. And you just calculate some specific characteristic from the objects which contains inside this bin. It's like calculation, it's like a comparison of the mean target inside this bin compared to the global mean. And on the top of these features, you just build a simple logistic regression model. And in this situation, you can receive so-called the scoring card. So if we take a look here, we have like minus 0.83 for ext source 2, and here we have the coefficient column. We have the same number here. And as we have ext source 1 here, we can also find it in classic scoring card and just take a look at the values of weight of evidence and just figure out that they are the same as this graph have. And more than that, all these graphs are not manually built. They built based on automatic LightAutoML report. So you just take one line of code to receive all of them. I will show how to do it later in the practice part. And now we can take a quick look into LightAutoML advantages for business. First of all, we can make models faster, and if we integrate it with inference environment, we can just rapidly do the way from the idea up to running model into production. And inside this step, we can build the model with LightAutoML. We can use this train model with the help of the serving script inside Sber Cloud build and deploy step using Hive serving technique. And this will be inside inference cluster, which goes for automatic scaling based on the number of requests from automated system from client side. So it should be pretty good latency for each amount of requests from the client side, and just don't waste money having much more servers up than you need. The second one is that LightAutoML can be the transfer and step for state-of-the-art solutions for data scientists inside your company, because it has a modular structure, and you just can create the new model with state-of-the-art solution, for example, with, for example, Cat Boost, if we don't have it, but we have it. Or you can create some feature engineering blocks and use it inside your pipelines to solve the tasks better. More than that, we are going to increase the quality of implemented models. And for now, we have several checks that we are working on the level of top 10% human data scientists. Why it is so? First one, we have a comparison from Google. They just compare their own AutoML, but the idea is pretty the same with our results. So they just calculate their own AutoML solution on some Kaggle task and receive this green line benchmark. And after that, the human DS just try to solve it as much as they can. And here we have just like bright blue dots. This is the submissions of people. And we can see that the top data scientists just beat the AutoML solution in several days. But if we go to this dotted blue line, it's just like 19th percentile of submissions. To beat the AutoML solution, we need about, I think, 2 or 3 weeks of time. So if you have pretty much time, you can do it. But almost always you have, for example, a week to do, a week to work on the same task. So it isn't so possible to spend, for example, a month on each business task, because you need to be faster. And the same situation we have on our inside hackathon called Next Hack. Here we have private leaderboard scores distribution, and we divided it into like blue or violet part, 90% of human DS. The red one is top 10%, and the green one, and I need to talk that LightAutoML won this competition. The green one is for AutoML. So we have done statistical tests here, and we have checked that AutoML solution has statistically better mean and statistically better variance, but than 90% of human DS. But for sure, it is not statistically better than 10% of human DS. Both on mean accuracy and mean variance. So this can help us to talk about 10% human DS level. And more than that, we participated with LightAutoML inside our competition called Megaphone Accelerator. They just want to find some interns inside Russia to work for them. It was a task for disbalanced multi-class classification. Here, 97 teams were participated, and the whole time for this competition was only 11 days. So it just less than 2 weeks. And here we built the solution based on AutoML, and it was built in 1.5 hours. And here we have finished on the 12th place out of 97 teams, with a huge jump from the public leaderboard to the private. So we have believed inside our model, and it just helps us to be better on private, on new data that nobody can see before. So that's look cool. Moreover, LightAutoML or AutoML solution is also a solution for long right tail problem. What it is a situation when during solving some business task, you need to build a lot of ML models based on different data sets, and these models are not economically efficient in each model is not economically efficient, but the whole profit from all of them is pretty much great. So here we have an example. We built 55 models during one weekend on the same mid-range server, just like I think 20 or 30 cores of CPU and just like 200 gigabytes of RAM. So on the graph here, we have the profits comparing with rule-based benchmarks for each model, build it manually. And here we can see that a lot of models have pretty small impact, and some of them have even negative impact. But if we calculate the sum of these profits, because they all solve the same business task, the full financial effect here is comparable with the effect for one of the most critical bank tasks. So it looks pretty good. For sure, we have we can take LightAutoML as a fast hypothesis checking tool. We can just figure out are the expert features we built, or should we use the new input source or something like that. We could also benchmark our models, build it manually, and we can do it pretty automatic. And the last but not the least advantage for business is the train test gap elimination. So we don't need to, as I stated before, we don't need to build the models for the centuries, or just put it into production today and wait for 2 years before updating it. Why it is possible? It is possible because we can transfer from current model building paradigm, when we just have a stable train and just predictions for different months. We can increment our training data, or just go with sliding window train, and have the no gap between train and test data. And so our model will have the most actual dependencies and the most actual situation. and should be better for the test data sets. And in the bottom of the slide, we have two different tasks solved with both of these techniques. So the green line is for the static models. So it has static train, and blue and red one are for dynamic ones. So blue is for cumulative train, so you just append new months into your train, and the red one is the window train. It's just when you add, for example, January 2019, you just drop January 2017, and for the same for February, March, and so on. And what we can see here, we found out that the green line is also is always in the bottom, but these two variants can be can depend for each task. So we can try them both and figure out what is the best for the current situation. But they both better than the static model. And for the conclusion for this theoretic part, I want to state that LightAutoML is a pretty good open source solution for developers, data scientists, and data analytics. You can take it from this GitHub link. We will go to it in several seconds. More than that, you can get it from PyPy. I also show how to do it. It is a pretty good tool for automatic model creation, which can build typical ML models in several minutes using just a laptop. And if you want to go with simple model training without any code and just inference your models for production, you can use Sber Cloud platform services called ML Space. We are just currently working on it, and I think we should release it somehow in the future, but it is almost ready. So that's all for theoretic part. So we can take some questions now if you have, and we will continue with practical part in several minutes after the questions. So if you have any questions, you can just put it into some chats on GitHub or on YouTube or something like that. I think that should work. Maybe. Or we can continue with practical part and just take the questions at the end.
Yeah, Alexander, I think let's continue.
Yeah, sure.
I think if there are any questions that come up, I will certainly share it towards the end with you.
Yeah, okay, sure. Okay, let me share another screen for this part. Here, I think here you can take a look on it. So first of all, here is our GitHub. So you can receive LightAutoML from here if you want to. So here we have all the codes, so all the parts inside LightAutoML is open. So feel free to take a look and make some contributions to it if necessary. So, as I stated, we can work with data sets for binary classification, for multi-class classification, and for regression. We are currently working with something like mixed data sets and multi-label tasks, but these ones are already done, and we can work with them right now. So here we have some video guides and articles about LightAutoML. We will take a look a little bit closer in a second. And here is the comment which can help you to install LightAutoML. It's just pretty simple. It's like pip install LightAutoML with update flag for the dependencies you have. We also have a documentation for our lib, which can be taken from here. Can show it pretty fast. It's like the Python API documentation, so you can go inside any block and just take a look what's going on, what are the arguments, and what we are stated for. So feel free to take a look and just find out if we have some questions about arguments. More than that, we have several communities for our library. We have a Slack community, which can be received from this button here. So if you click on it, you just came to this link, and you just input your email address, just put a tick that you are not a robot. I'm sure you are not. And just click join to receive the invite to our Slack. And the same situation for the Telegram chat. Currently it is in Russian, but I think we can make more English posts if we receive some requests for it. So we can, and as well, we have different tutorials. For now, they can be opened inside Colab. Just click the button and take a look on the tutorial in Colab. And as well, we have a lot of tutorials on Kaggle, and we will take a look on them in a minute. So, what are the articles for LightAutoML? The main one is mine article in Towards Data Science, and in the beginning it shows how to train the model on Titanic dataset just in 12 lines of code. Including 4 lines for imports, 3 blank lines for better reading, and only 3 lines of building the model itself. So this model is pretty simple, but it receives I think almost 78% on Titanic dataset. You can check it in this kernel built by me. So it's like 77.99, so almost 78%, and the code is the same. And after that, it describes how to build another kernel, which has a little bit better score, but this another kernel can be used as a template for a real business ML solution. So you can just take it and just put new data inside it and figure out what's going on with your own data using LightAutoML. So we will take a look at some parts of it. First of all, we need to import necessary libraries, the standard Python ones, some installed ones like NumPy or Pandas. and and sklearn as well for metrics and model selection. And we have some imports from LightAutoML package. These are two presets from our package, and the task is as a description for the task we solve. So after that, we just load the data sets, the train data, the test data, and the sample submission. And after that, we can insert the block with some export feature creation. So here I just show how to generate some new features for Titanic dataset. It's just pretty common. So you just found out what is the ticket type, taking it from the ticket column. You just figure out that the passenger has cabin or not, calculate the family size, find out what is the title for the person, and put them all inside the train and test data just to try to improve your score for the kernel. And after that, just to figure out how good your model is, you need to split your data for train and validation parts. So here we done it using train test split from sklearn. We just stated random state to be reproducible. And for now, we have tier data for training, valid data for just figuring out how good the model is, and the test data to submit to Kaggle. So first of all, we need to state what task we solve. And here we have different options. As I said, we have binary for binary classification, we have reg for regression, and we have multiclass for multiclass classification. And here, as we know, we have binary classification tasks, so survived, non-survived. And as we have accuracy for this type of model, I will try to insert here the F1 metric, which can build a model which is stable for precision and recall both, not only for accuracy. So in my opinion, it's just a better option. So I just tried to do it here. And the one point I want to introduce here, that you can just put inside task your own metrics, just creating the functions like this, like usual sklearn metrics. So you can use sample weights and other parameters which usual sklearn metrics have here. And we can take a look about it in the near future. But here we put inside F1 metric as a metric for our model. The second part here is setting the column rows. You must input the target one, but you can also help the model to be better, saying that it should drop some columns from the data set. For example, here I just tell it that I don't want to use passenger ID, name, or ticket inside the model, and it will drop it before the training. And after that, I want to use such pipeline. So it just started from data and ended with predictions. And inside it has 3 different algorithms with 2 different feature preprocessing steps and a weighted blender on the top. And all this pipeline can be stated just like with this type of row. So here we use tabular AutoML preset from LightAutoML with the task we defined before, with timeout as 600 seconds, like 10 minutes. We have a CPU limit set it for 4. It's optimal for Kaggle kernels, as you know. And more than that, we can just choose some parameters for this preset. For example, we can just set several algorithms we want to use here. So we use here linear L2, LGB, and LGB tuned. And what are the algorithms state by these names? So we have the linear model called linear L2, just pretty simple. We have LightGBM model with expert params called LGB. We have LightGBM with tuned params using Aptuna. It's LGB tuned. And the same for CatBoost. It's CB and CB tuned for expert params and for Aptuna. So we can combine this type of algorithms as much as we can and as much as we want. And even more, we can build the stacking. We can use the stacking technique inside our preset, just setting the use algos, just like this list consisting of 2 different lists. And here we have on the first level 3 models for the first level, so linear model, LightGBM, and CatBoost. And we have 2 algorithms on the second level, just like tuned LightGBM and almost the same CatBoost, but build it not on the usual input features, but on the head of out-of-fault predictions from this algorithm. And as we stated 2 algorithms for the last level, we need to combine them with a weighted average composition on the third level, but it is not stated here. And if we want to figure out what are all the parameters we can set for tabular AutoML preset, because as we stated in the theory part, we should be pretty much customizable. You can find it inside YAML config for this preset. Here it looks like, so we can take a look at it. It's pretty commented, so we have different params for each step of ML pipeline. So if we go from top to bottom, it's like general params with use algos, which one we set. We have some skip connections. We have reader params for figuring out what are the situations with input data. We have selection params for different feature selections variants. We have tuning params, like GBM params, CatBoost params, and so on. So we can go as much deep as we can as we want to into this config and just customize our preset for each task if it is necessary. And to fit the model, you just need to call fit predict function with the training data. So it's here third data. And the roles, we set it up. So it's just like target and features to drop. To receive the predictions here, we need to call the predict function. And the valid data goes to this function, and we receive the validation predict. So if we take a look for the scores, and for sure we need to take a look for accuracy scores, as this is the metric for Titanic task. We receive pretty good results. We have 84.4 accuracy for out of fault predictions, and 83.2% for validation data in just 2.5 minutes. So it's pretty fast, and we want more accuracy to receive and to be higher in leaderboard. So we try to use tabular utilized AutoML preset. It is the same, almost the same as tabular AutoML, but here we try to spend our timeout as much as possible, building different models inside this timeout. So the API is almost the same here, and here just the same as we have for tabular AutoML. For fit predict and predict, the API is just the same. And if we check the scores, now we have 85.5 for out of fault and 82.7 for validation data, in less than 9 minutes. So it is just inside our timeout, which was 10 minutes. And we receive better scores for out of fault and a little bit worse score for validation data. But for validation, we use only 179 passengers. So it's better here to take a look on out of fault score because it just have more data under it. And if we take a look at out of fault, it is more than a percent advantage. So we use it to retrain on the whole data set. So we just here stated once again the tabular utilized AutoML and fit predicted with the whole training data we have, and make a prediction for the test data we have, and prepare a solution for Kaggle. And if we submit it to Kaggle, we receive 79 almost 80% for accuracy for Titanic. So it's a pretty good one. And as you can see from the steps, you can just replace the data set for this task with your own data set. You can just create some new expert features if you want to. And just check how LightAutoML works on your own task. And for sure, as I stated, we have the kernel solution for this particular task. So here we have the same score as I stated in the article. And here are the same steps we covered before. So just like creating features, data splitting, create task, set up column roles, and so on. So, okay, here we solve just like binary classification task, but what can we do for example, regression task? To go to regression task, we can just check something like house prices model or house prices data set. Let me share the screen for it. And for the first version, our Kaggle kernels are just pretty dropped. Okay. That's cool that I just lowered it before. Okay, just as a quick reminder for house prices, what we need to do to make regression is just like change binary for reg here, and that's all. So we and for example, we can change the metric. But regression with F1 metric will work as well, as you know, because it's pretty normal to do that. So you just change the binary for rec, and you can solve a regression task. Or you can just change it to multi-class and solve a multi-class task. Okay, as we have only several kernels up because I just loaded them manually, I think yesterday, in this situation we can try to find out how to work with AutoML library. It is a part of LightAutoML and stands for white box AutoML for interpretable models. So here, what we have here, we just installed AutoML library. It is the same like LightAutoML, but the changed name of the library. Again, we just import some libraries we need to work, and we import AutoML. Again, we load the data for the competition. Here is the competition called Tabular Playground Series for the April. And it is just like Titanic or Syntanic data set. So just Titanic from CityGun model. And here we have 100,000 of rows for train and for test. And we need to make some predictions for the test data set based on our models, and we need to predict not probabilities but classes, because we calculate accuracy score here. We also create some new features. For example, here we built the cabin and the ticket feature. We just receive some letters from the beginning of each feature. We also calculate some family size and build new features based on first name and surname, but they don't work. But we just try to implement them here. And after that, we just again separate the data using train test split and set up the random state. And here we just set our model with several params included. In just the simple ones like n jobs for the number of threads to use, and false for inner cross-validation and something like that. But the main idea here is again to train this model. You just need to write only one line of code with fit method with training data and target name. We just wait a little bit, like 4.5 minutes, for the data set about like 100,000 of rows or something like that. And here we receive the accuracy score like 77.6. It's pretty good for this competition. It was even better for it was even better than LightGBM and CatBoost solutions, so it was pretty cool here. And we have two bonus parts for these interpretable models. First of all, we can build automatic report for the trained model, and I hope it can be loaded from here. Oops. So the problem states here, and as I don't load it before, we can't see it. But the main idea here is that it is just a little bit interactive. Just you can open subtree called the black triangle on the left of each text, and just go deeper inside this report. And if we had, if it is possible to have a look on this report, we can see that the sex feature is the most important feature for this model, and it just has pretty big coefficient comparing with other features, and so on. You just find out that something strange goes with this type of feature. And if we compare weight of evidence numbers for males and females, it just crazy goes in different directions. So the weight of evidence for males are, for example, positive, and for females are negative. So it just really different. So we just figure out that we need something to do with the sex feature, and we will do it later in this kernel. And the second bonus part is that we can create automatic SQL inference query for the trained model. As we stated, it is just like a scoring card. So we can create the SQL inference query with the simple line of code. So we just want to get SQL inference query. We set the table name with the initial features called table name. And here we can see that the SQL query was generated, and we receive the predictions for this type of model inside the database. So we don't need to waste time and to just load data to the Python server to make predictions and to send the predictions again to the database. So we can just do everything inside the database. And here we can see that weight of evidence for female is minus 1.1, almost 1.2, and for male it is 1.05. So just pretty separated and just far away from each other. And that shows me that possibly it will be better to create two different models separated by sex. And what we have done here, we just train male and female models. They just created here again for several minutes for each one. After that, we receive male predictions and female predictions, and just combine them into the one prediction based on the sex column inside the test dataset. And so we create the submission for it, just a simple 0.5 boundary cut. And here we receive the submission file. And as we go for the scores, we can take a look that it has 0.81 347. So it's even better than different black box models for this competition. So sometimes if you have really messy data with a great amount of noise, which was produced by, I don't know, some sensors, or for here it was Citizen model, It could be better to use simpler but robust models to receive better scores. So just don't forget about it when you try to solve competitions or your own business tasks. And once again, we have different solutions for other competitions. Fast. We will take a fast look because the template is the same, but the data sets are different. So here we have just long default prediction. And it was like a pretty simple competition with only 2 teams. And for me, it was the score like 78. It was received by small amount of time, and this competition was like from April 23 up to April 24. It was like 20 hours to compete inside this competition. But for us, it was a pretty simple story. So we have a solution just less than an hour. And it was pretty good for this type of data set. And once again, the template is the same for this competition. So we just load the data, create some new features like combinations of different dates, just creation features from different string features, and so on. We split the data for train and test, or train and validation. Just set up the task, the column rows, and train tabular AutoML, for example, and receive the scores. Train AutoML with utilization, so tabular utilized AutoML, and figure out that in this particular task, tabular utilized is a little bit worse than tabular AutoML, and we use here tabular AutoML as a model for the final retrain, and receive the results and prepare the submission. And the same situation is for our LightAutoML course homework. Once again, we install the library, we set up params, we just load the data set, and here we have the regression data set, so we need to predict the final price for these cars. And here, what we do here, we just set task for regression, and it's pretty much the same as the previous kernel. So we again train tabular AutoML, for example. We can take a look on feature importances which received from our model. So here, what the doors count is the most important feature for this type of model. And we generate submission and submit it to Kaggle. So for now, as it is a homework for our students, so we can take a look at the leaderboard. So we have different baselines based on LightAutoML, and some simple ones based on mean and median for the target. And currently, the LightAutoML strong baseline and one more LightAutoML solution are pretty good one inside this type of competition. But it is just the beginning of the homework, so I think people can do the better models in this particular task. So the key point of all of these ideas and all of these kernels are that you just have a simple template that was shown inside the article, and the only thing you need to do to solve your own task is to just load new data set, maybe create expert features if you want to, and just change the task for the appropriate value, and to set up the target variable you have for the current data set you have. So, and after that, you just train models in just several lines of code, and you can think about new expert features and new strategies and new metrics during the LightAutoML train your current version of model. And this is pretty cool for benchmarking models, for testing hypotheses. So it is pretty cool for the data scientists to work with. So that's, I think that's all for the practice part. So I think it's time for questions, as we can't load anything else from Kaggle because it's just down for some time. It was down from the beginning of the day, and we just can't load any kernel. Any more kernel before I just can go live once again.
Thanks, Alexander. I think quite a few questions. There's one from Ankit. I think you talked about this a while back about cross validation and stuff. But
Yep.
Let me ask. It's like how to ensure that the AutoML model is not overfitting on the data, and if it's how do you select the right model?
Okay. So to figure out that you're not overfitted, you just receive so-called out-of-fault predictions. So I can show it here. So here you receive out-of-fault predictions, which were built based on our inner cross-validation scheme. And you can just check how it compares with the test data set and how it compares with validation data. So you can just figure out how it works and does it overfit or not. And there could be different situations for sure. You can receive the situation when you have the leak inside your data set, and the model you built for sure will be overfitted. But when you try to predict for validation data, that's why I just stated here the separation for train and validation. You just receive bad score. And if you try to, for example, take a look at, we just, I think, lose the kernel. Yep, we just lose the kernel, but I'll try to find out some variants to receive the feature importance graph. So if you find out that you have some feature, some strange feature at the top of your kernel, and at the top of the importance of your model, so you just can find out that something goes strange, and you just need to more properly take a look at this kind of feature, and just find out you should drop it or you should just build the new features based on that or things like that. So the idea here is just pretty common. So you just can try to find out that something goes wrong based on the objects you receive from the trained model.
Ankit, I hope that answered your question. I guess so. We'll wait. I had a question on the explainability part. I think the way you guys did the SQL part is, I think, probably one of the most creative way that I've seen somebody do interpretability. And I think it's pretty useful. So I think that certainly I have a lot of use cases at work that I'm going to probably make use of it and try it out and see how that works. But as I kind of thought about some of these problems, right? The weight of evidence is kind of mainly using, for binary classification and stuff. Like, how does it scale to like multi-class that you guys take care of the binarization internally?
Yeah, sure. Oh, sorry. So we for sure have different variants for binary classification and for multi-class classification. So it is not just simple one-way solve. It's a real multi-class classification solution. So we built different types of features for the multi-class situation because, as you know, we can't do simple mean target encoding because we have different classes. So it should be not only one column, but several columns. And we need to figure out which one to leave and which one to stay. And for sure, here we can customize our model better. For example, for multi-class tasks, we found out on our own benchmarks inside the bank and inside different testing stage that for multi-class it's even better to use stacking, two-level stacking as a default composition. So for the first level, you just build the predictions from different algorithms based on initial features. And as you receive the probabilities for each class from different models, you can just combine them using new models on the second level, and they just find out some interactions between probabilities, and it works pretty good on our benchmarks. And as I can see the question from the chat, yes, we for sure have an opportunity to set up the models inside our AutoML. I can show it pretty quick. For example, let me find the kernel. Here. So here we use free algorithms on the first level of staking, and as we don't have the second one will be just a weighted average composition, which can drop not necessary models to make the model faster. And if you need to, for example, build the staking like with 3 or 4 levels, so you can do it really quick. You can just set, for example, use algos. So with one param, you can set it, for example, for this list. Or even more list inside this outer one. So you can just take a copy of it and just put it after that. And in this situation, you receive 4-level stacking if you just copy this one after that. And on the 5th level, you receive the weighted blender, which combine different predictions into one final prediction. So you can just customize it as much as you want. And as I stated before, you can take a look at this YAML config here. And here you can customize almost everything inside our pipeline. For example, you can even customize that you want iterative selection for feature selection, or you don't, or you want to tune your parameters for the model not only on holdout or on the last cross-validation fault, but on the full cross-validation. For sure, if you train and if you find your params on holdout, it's pretty fast, but maybe not accurate. And if you just train and try to find the params on the whole cross-validation, it not so fast, but it's pretty much accurate. So you can just combine different variants here and just set up them as much, and you can just customize it as much as you want.
So just on this, right, I was going through the code earlier, and I saw that for example, LightGBM, Cat Boost, you guys have set up some default parameters based on the number of rows, based on the data that you see. How did you guys arrive at that? Like, was it based on your experience as a Kaggle Grandmaster, or
Here I need to state one more point. Let me return back to my article on Medium. So here we have, it's just a little bit crazy internet. Let me show all of our algorithms inside. So here it is. So we have 5 different types of algorithms, as we stated here, and the order of them is pretty important. So they trained in this type of order because we need to be on time, we need to be inside the timeout, and we have linear model first. It works almost rapidly. And for every situation, and even for I think 30 seconds, we can receive the full prediction from linear model. And after that, we train LightGBM with expert params. Yes, they are based on our Kaggle experience. They are based on different specifics of the data set, the number of rows, and things like that. And after that, if we have time, so we just not going out of the timeout, we can just try to find some better params, maybe using Neptuna. But as we have some opinion, we just received some results that for big data sets, hyperparameter optimization is less important than for small ones. So we just here works pretty fine. So if you have a small data set, you just build 2 first models pretty quick and have enough time to find out the tune params, and they are pretty fine founded here. And if you have a big data set where some dependencies are pretty clear, and almost every params for LightGBM or Cat Boost are pretty much the same. We are not including here the really worst params like max depth equal to 1 or something like that. But almost the same, almost all params for the big data sets are almost at the same quality. And here we just train, we spent more time on model with expert params, and have almost no time if the timeout is pretty much small. We have almost no time for tune params, but don't really give here the advantage, because we already receive almost everything from the first LightGBM. So the idea here is that you train your models based on their speed, and you just try to receive as much as possible for each timeout you have.
Got it. So, and I think with the combination of, how to pick those models and this, you can, decide if you want to skip certain models and give some more time for
Yeah,
for
sure.
training.
Yeah, sure. If you skip some models, it just find out that it has more time to another models, and if you just for example, it can share some amount of time for linear model, and the linear model just do everything pretty quick, and we have the spare time for the linear model, like for example 10 seconds, and these 10 seconds go to the bank, and it just split it into equal parts for the algorithm which goes after the linear model. So we just repartition our timeout for another algorithm.
Cool. Any other questions from the audience? I guess not. I guess we leave it at that. Thanks a lot, Alexander. I think this was pretty in depth, and I think probably you looked at a lot of tools itself. I think with your vision that you guys are saying, hey, model monitoring, distillation, and others. I think this will be one of the pretty much free and state of the art models that are out there to kind of work with it. So I think pretty excited to look forward to what you guys come up with next.
Yeah, we are trying here to build the open source framework, because we figure out that we should try to share our experience with the audience, with other data scientists which wants to build better models, which wants to make them automatically, and for sure we just find out that if we open source our solution, we can receive even more. We can receive the opinion from the crowd, and we can figure out what the community wants to implement inside our framework. And for sure, we are ready for some contributions inside our framework. So if you want to have some feature implemented, you can just make a pull request to our framework, and it will work inside our framework for sure. As I stated, we can build some customized blocks. I have an example for that, but I think for today we can't just load it. Sorry. If we go for my page, we can find out it's on the bottom. So we have here custom ML pipeline elements inside existing ones. So in this example, we just create the new pipeline, the new feature transformer for the existing pipeline, and we just received a little bit better quality for some specific task using LightAutoML. So it's just open question and just open framework to try to implement your own ideas, and try to check your own ideas.
All right. Just one last thing. In your, the roadmap that you guys were sharing, you mentioned about distillation itself. Is the idea that you guys will be getting, deep learning models in there, going towards NLP, computer vision, or is it still going to be related to tabular data sets?
Here we have, I should state it that currently we have already implemented NLP pipeline, so we can work with NLP data. So here, for example, we have an example with natural language processing for disaster tweet competition. So usually inside our business data sets, so we also have text data, for example, like customers reviews, like transcribed audio and something like that. So we also should work with them. And currently we also have a small part of computer vision pipeline, but currently it is not so powerful as other ones. But we are still working on it because it's like NLP pipeline, but with different types of models. So we just try to make it better, and we are looking forward to implement some interesting features inside it.
Nice. I think this is something that I'm going to certainly follow. And these tutorials that you have, I was seeing some data science courses. Is this something that non-Russian speakers can participate as well, or?
As for this particular situation, currently we are working on the course for the Russian speakers, but we are also thinking about creating a YouTube channel or something like that with some explanations of Kaggle kernels, solutions with LightAutoML, and we are currently thinking about something like a Coursera course about LightAutoML or something like that. So we are thinking about our audience, and currently we are just waiting for the solution for our paper about LightAutoML, and if it goes okay, I think we will do that stuff.
Cool. I think, yeah, it looks like a pretty exciting roadmap that you guys have. So I guess pretty amazing. Thanks for your time, Alexander. Let me just check if there are any more questions. Probably none. I think I'll let you go. It's Saturday evening for you as well. Thanks for your time, and yeah, looking forward to more stuff on LightAutoML.
Yeah, thank you for inviting me, and thank you for all being with us. So we will be happy to answer your questions if you have some in our GitHub on issues, and we will be happy for your stars if you like it on GitHub. So thank you for joining us.
Absolutely. Thanks, Alexander. Have a wonderful day.
Yeah, you too.